A volcano is a pressure valve to Earth's molten heart. Magma, gas, and crystals rise through fractures to the surface. Under immense pressure, dissolved gases seek escape. When a weak point opens, eruption follows. Think of shaking a soda, then cracking the cap. Eruptions vent lava, ash, and powerful gases skyward. Space is sprinkled with asteroids, comets, and meteoroids. Their paths sometimes intersect with Earth's orbit. Atmospheric friction ignites a meteor's brilliant trail. If it reaches the surface, we call it a meteorite. Now, imagine a meteorite falling into an active volcano. Upward Earth energy meets downward cosmic impact. In microseconds, kinetic energy becomes heat, light, and blast. A cascade begins: ground shocks, explosive ejection, towering ash. We will track immediate effects to global climate ripples. On contact, the meteorite likely vaporizes in superheated magma. External force ejects magma outward and upward, violently. Crater walls fracture, hot rock and ash rain across slopes. If a lava lake exists, a colossal molten splash follows. A heat flash ignites wildfires before the shock arrives. Meteor metals mix in, subtly tweaking eruption chemistry. Impact shock travels into the crust, striking the magma chamber. Gas exsolves, like opening shaken soda, spiking pressure. Surrounding rock fractures, creating expressways to the surface. Buoyant, gas-rich magma races upward with little cooling. Style shifts to explosive. Ash and pumice dominate. Roof segments can collapse, pistoning magma upward. In extreme cases, a caldera-forming super eruption. The landscape is permanently and fundamentally altered. Shockwaves radiate through air and rock, an induced earthquake. Expect intense local quakes and aftershocks. Steep slopes fail. Debris avalanches cascade downslope. Shared plumbing can awaken adjacent vents and fissures. New fractures may open far from the crater. Groundwater flash boils, triggering phreatic explosions. A regional volcanic crisis can unfold. Shaking liquefies saturated soils. Ground loses strength. Structures can sink or deform unexpectedly. Aquifers rupture. Underground flow paths are rerouted. Heat and shaking melt snow and ice quickly. Lahars, wet concrete rivers, bury valleys and towns. The shockwave is an invisible architect of chaos. Impact-amplified eruption drives ash far into the stratosphere. Volcanic ash is sharp rock and glass, not soft soot. Jet streams stretch the cloud worldwide in days to weeks. Sunlight dims, regions slip into a sinister twilight. Near the volcano, ash buries roofs and crops. In jets, ash melts and refreezes on turbines. Engines fail. Airspace closures stall travel and commerce. Inhaled ash scars lungs. Respiratory risk surges. Global fallout alters soils and stresses marine life. Sulfur dioxide injects into the stratosphere. It forms reflective sulfuric acid aerosols. These droplets scatter sunlight back to space. Skies whiten. Sunsets blaze with unusual colors. Surface temperatures drop rapidly and unevenly. Winds shift. Rainfall redistributes. Storms reorganize. Aerosols foster ozone loss. UV exposure increases temporarily. Plants and skin face added UV stress during recovery. Aerosol veils can cool Earth for 1 to 3 years, or more. Shorter, cooler growing seasons threaten harvests. Crop failures can trigger food crises and instability. Reduced light weakens marine food webs and fisheries. Some regions dry and dust, others flood under new patterns. Sea ice and currents adjust, reshaping climate rhythms. As aerosols fall, sunlight returns and temperatures rebound, but ecological and social scars can endure for decades. Studying this scenario sharpens planetary defense. Find threats early, nudge dangerous asteroids off course. Simulations test impacts, eruptions, and ash dispersion. Models guide evacuations and protect global food supplies. Nature's power reminds us of our fragility and our agency. Through observation and modeling, preparedness grows. We can look outward and inward to protect our future. Confronted by immense natural forces, how will we wield our growing power of understanding?